long runs. Nobody knows actually whether he actually sleeps or not. Please, with a big round of applause, welcome Nigel.
It was an old introduction. These days I do really sleep. So I am the Gluster CI architect. I work at Red Hat. What I do is I make sure that Gluster as a project has a green pipeline. The tests work. If you want to run a new test, I'm the guy who'll set it up for you. I set the infrastructure up for running tests, for hosting the code. If things are slow, I'm the guy who's going to be fixing it. And this talk is about all the mistakes I've made over my career. It's not a lot about Python. I mean, I show some Python code, but it isn't particularly Python specific. It's sort of knowledge that works across languages. It's more about process and what I've learned over the last 6-7 years that I've been working as a programmer. If I seem really nervous, that's because I really am nervous. This is a reasonably large crowd, and I look and I'm like, oh, this is a lot of people. So writing code is kind of easy. I mean, when you start out, writing code seems like a difficult task, but honestly, after a few years of working, writing code is the easy part. Cutting a release is slightly more difficult because there's a lot of things that you have to think about. There's a lot of factors in a release. There's a lot of planning that goes into it. There's a lot of processes that happen. Now, getting people to trust that your releases work, getting people to upgrade to the newest version that you've released is slightly more challenging than even cutting a release. Now, if you've screwed up, if you've messed up in one of your releases, people don't really trust your product anymore. And if you want to regain their trust, you have to go through this challenge of showing them that, yes, I've done my homework, we screwed up, but now we're actually doing a better job than we used to, and you can actually trust our product. So what is the worst that could possibly happen? Let's think about an imaginary company called Acme Inc. If that name doesn't ring a bell, this might help. If it doesn't help, then I feel really, really old. So imagine Acme had a very successful 1.0 series of product. Taking this image, maybe they had a web catalog, and it was organically grown. They started off with a very simple PHP application, and then they were like, oh, we want to add a different feature, and we want to add a different feature. And now it's at 1.9, and it's really slow, doesn't work very well. Salespeople aren't happy because people aren't buying things because when they click pay, it takes about 30 seconds to work. If you search, it doesn't work. There's not much documentation for this software project. We were talking about salespeople earlier and stereotypes. You do have to care about salespeople. Eventually, they're the people who make sure you get paid a salary. If they don't make sales, you're not going to get paid. Now, as software engineers, we have this intense desire at some point to say, this code base sucks. I'm going to throw it out, and I'm going to start over, and I'm going to do things right this time. Practically everybody who's worked for 2 years or more have gone through this at some point, or have thought of going through this. Let me tell you, it's a really, really bad idea. I've done it a few times, and it's always ended up badly. Now, our imaginary company decides that for 2.0, they have to do something really different because the 1.9 version is kind of bad. People aren't really buying their product. They have to up their game. In the past, they used to release every 6 months. And this time they decided, you know what? We're going to take one release off. So we're going to release 1 year later. And we're going to spend more time in engineering. We're going to spend more time developing our new code base. And let's see what we can come up with. What could possibly happen? What do you think happens? What's happened is there's just fires all around. They're late by, so they had a 1 year deadline. It's now 1 year, 3 months. There is no hope of a release yet. The documentation that they used to have was bad. Now it's even worse because they changed the APIs, and you don't know which documentation points to the new API and which one points to the old API. They had tests, but now most of them fail, and they don't know if it's because there's a timing issue or if it's because you completely broke the functionality because of the new rewrite. And the UI is still buggy. If developers want to consume their application to build something on top of it, they're not very happy with it because the API is sort of inconsistent now. There are some performance problems while they fix the bugs. When I thought of this as an imaginary scenario, I wrote it down and I realized I've been part of 3 different projects where this happened, and I've been part of it at different stages. Once in the middle of the transition, I was a junior developer. Once before the transition, and once after the transition. After the transition is fun. You're dealing with somebody who comes and files a bug saying, hey, so 1.9 had this feature where if you do this, it would work. But that was actually a bug, and somebody was depending on that bug. Now you fix the bug, and they're pissed because you've broken their workflow. This sort of problem tends to happen quite a lot when you work on an application that has a lot of components. And now that you've broken your 2.0 release, the community doesn't trust you. People don't want to buy your product. And the morale in your team is really low. I mean, we like to build things. When people don't like what we build, it's not like we're going to be really, really happy about it. So what went wrong here? There are a couple of things that I think went wrong. I'm sure there are more. I'm sort of highlighting 4 of the things that I think really, really went wrong. And if they'd thought of fixing it up, things wouldn't have been as bad as they are now. And so there's 4 things. I have about half an hour, 35 minutes. So I'm hoping I can cover all of them and have some time for questions. So the first thing is cadence. So as my intro said, I'm a runner. So for the runner, a cadence is the number of steps that you take in a minute. So people who are pro runners will tell you that there is a certain cadence that you need to maintain. If you take 180 steps per minute, that's the ideal cadence that you need to maintain. If you take less steps per minute, that means you are stressing the wrong part of your body. That means your knees are above your body weight, which means the stress of running is on your knees. And if you take more steps per minute than 180, you are running inefficiently. In a software release, a cadence is really important. There is a flow in how things work. As in, you spend, if it's a 6-month release cycle, you spend about 4 months in development, hopefully. I mean, you might spend some more, but you need at least a 1-month to 2-month period where your focus is, we've put all the code that we can put into this release, and now we want to make sure that it hasn't broken anything. You want to test. You want to make sure that your documentation is up to date for all the changes you've made. When you increase your cadence, so when you slow down your cadence, as these guys did, you realize that you think you've got a 6-month cadence, so you now have made it 1 year. So you think you have 9 months to 8 or 10 months to write code, but you don't. Because when you decrease your cadence, the amount of time required to test this release also increases. The amount of effort it takes to write documentation for this release also increases. So when you increase the time you have for the release, you are not helping yourself get a lot of time for writing code. You are increasing the effort it takes to test that release. You're increasing the effort it takes to maintain the documentation for that release. If you decide that you're going to release faster, you're putting pressure on your release systems. This could be that your tests take 1 day to run, and if you release every 3 months, you probably can't test well enough. Or it could be a large number of things. I don't have an advice on what's the best cadence for your team, like I have with running, because it really depends on your workflow. It depends on what your application does. If you're developing a web application, it makes a lot of sense that you want to deploy it several times a day. That's what most people do these days. I mean, when I started my first job, a deployment was, okay, so I've got all this PHP code, and I'm going to log into FTP and copy all these files there. That was considered deployment. What I could do is I could break it because somebody else had uploaded a file and overwritten my changes. So lots of things could break. And if I wanted to go faster at that point, I could automate it by saying, I'm going to do a git pull on the server rather than an FTP upload, because that'll just pull in the latest changes. And then you realize, hey, I have tests. I can't deploy a version where the tests failed. So then you say, okay, I'm going to write a script that will pull the last revision where the test passed. Slightly better. What about documentation? So you need to remember that as your cadence changes, your release tools and your release process can catch up with that cadence. When you decrease or increase your cadence, you tend to forget that all of these other things that are part of releasing a software also need their own time. Right. When you automate things, this is a XKCD from, I think, a couple of years ago. When you automate things, it's also important to figure out how much time you spend automating it. This sort of tells you how often you do the task and how much time it takes to run the task and whether it's worth automating it. What this doesn't tell you is if you accidentally make a mistake by doing something manually, how much time you're going to spend fixing that up. Last week, I think it was last week, GitLab accidentally deleted their production database and they had an outage for quite a long time. I feel really bad for the ops people because that is pretty much my nightmare situation, and I've done it a couple of times. I've run rm-rf on the root directory on a production server. That did not end well. It didn't help that this was a NetBSD machine and I'm a Linux guy. I have no idea how NetBSD works, except for the fact that rm-rf does work. And that's when I realized I probably shouldn't have done this command manually. I should have automated this so that I don't have any input there. It just sort of does the right thing without me having to mess with it. What happened is there was supposed to be an environment variable that I had to declare, and I forgot to declare it. So the environment variable was empty. There was just a slash, and it just deleted this root directory. It's an expensive mistake. Now, you can't, so when you try to decrease your cadence, you realize that you can't just say, assuming you want to release every 3 months, you can't just say, I have this big feature that's going to take 1 year to develop because it's modifying large parts of the code base. That is a challenging change. I mean, you can't just land that at the start of a cycle and say, okay, I've made this large change. Now let's see if everything works with this change. That's like a bad thing to do for the rest of your team. Like if you make a large change to a code base and say, hey, so I've changed how everything works behind the scenes, and now let's see if you can land more changes on top of this. Don't do that. That's evil. Now, if you have a big feature, the sort of accepted knowledge is you put it behind a feature flag. You say, when this flag is turned on, use this code path, and when that flag is turned off, don't use that code path. A big example that I have for this is what Mozilla did. Firefox, for the longest time, is a single process browser. So if one tab crashes, Firefox completely crashes, and you get this pop-up saying Firefox crashed, and you can restart. Now, if you're a person with, I usually have 10 tabs at most, but I know people who have 600 tabs. I don't know what they do with it. I just know that they have 600 tabs. And I don't know what it is that people use, why people don't use bookmarks instead, but they tend to do it. And Mozilla decided that Chrome's got multi-process, why don't we do it? So the project was called Electrolysis, and they spent a lot of time planning it out. And what they did was have Firefox run its DOM, which is the sort of everything about the browser except the web pages in one process, and each of the content processes in a separate process. So they first landed the code and turned on the preference for nightly users in Firefox 40. Firefox release cycle is every 6 weeks. So they spent a considerable amount of time writing this code. They landed it. It was still prefed off. The preference was still off. You could turn it on. It was not a compile time flag. It was a runtime flag. So if you had any version of Firefox where this code landed, you could run it. They first turned it on by default for nightly users in Firefox 40. Nightly is your master. You can do whatever you want in master. The people who run nightly know that it's not expected to be really stable for daily use, because this is where people test things. It was okay for nightly to be slightly broken, because then you get feedback from the rest of the team saying, hey, so I turned on electrolysis and this extension broke along with the other 3 extensions that broke. So we should probably be fixing that, and there's a bug on file for it. So you can test it at the same time your release users still have a stable version of Firefox. Then there's Aurora. Aurora is what is now called Firefox Developer Edition. They turn it on for those people in Firefox 42. So a full 40 after 6 weeks becomes Aurora. So a full 3 cycles later is when Aurora users or Developer Edition users got multiprocess Firefox. These are developers. They expect a little more stability. They expect that they can do their work. It's sort of the place where if you're a web developer, you want to use nightly, you want to use Aurora because it gives you the latest developer tools to play with. And they tested a lot of it with that version. Beta is sort of, people expect a lot more stability. You want the new tools, but you don't really want to run the latest and greatest. So they turned it on in beta for the first time in 44. This is not fully turned on. It was turned on for a subset of users. I think by the time beta, the full range of users got multiprocess Firefox, it was a few more releases later. I think it was 48. 49 is when they decided multiprocess is going to be turned on for about 30% of users. They had a certain criteria where they could evaluate if you don't have any add-ons installed and if you don't use accessibility features, this will be automatically turned on for you. If you've used accessibility features in the last 30 days or you don't have add-ons, it will still be turned off. The current Firefox release in the release channel is 50. So it's only been 2 releases since they released this feature. 40 was in, I think, August of last year or sometime before that. So this feature has been in development for a really long time, but they've gotten it out to a subset of their users. People have tested it. They found bugs. It's a large feature, but the idea is they still have 6-week-long release cycles. They can maintain their cadence without putting the users at risk because of landing such a large change. And this changes a lot of their internal APIs, so they could sort of make sure that we've tested this enough that we know these are the things that will break, and we know this is the limitations that this browser has when you turn this feature on. So this is pretty much all I have for Cadence, which is make sure you have a cadence, stick to it. When you change your cadence, you change a lot more things, and keep that in mind. The next big thing is documentation. I wanted a better picture, but this was the cutest I could find, so I just ran with it. We've had a talk already about the importance of documentation. I actually didn't look at the schedule very well. If I'd known there was a talk about documentation, I would have skipped through this. So I have a couple of slides about this. Anybody uses Nginx? Anybody used Nginx before it was very common? You know, the days when it was just reasonably new sort of web server. Do you remember how bad the documentation was back then? There was just wiki pages and Stack Overflow, and there were some answers to your problems, but you weren't quite sure if they were right. Sometimes they were straight up wrong. I remember one particular instance where if you wanted to redirect from HTTP to HTTPS, people would suggest you do a regex, but that was the wrong way to go about it. There was an easier and far better way that they finally documented in their wiki pages. These are the things you should not do. And over the years, when you have a project evolve, the documentation becomes better. But if your documentation sucks right now, you've sort of, I mean, when I want to use a project, I'm going to look at the documentation to evaluate whether I want to use this project. If the documentation is bad, I'm going to go, okay, I don't see the value in using Nginx over Apache. I mean, Apache has great documentation. If I'm lost, there is plenty of help on the internet. It's been around for so long that practically everybody knows how it works. Now, so that's the sort of big picture view of why documentation is important. Now, a more nuanced view is just having documentation isn't enough. It needs to be versioned. If you remember, Apache changed how some things are defined between 2.4 and 2.2. So 2.4 works very differently from 2.2. The same way that Python 3 and Python 2 are different, there are small subtle changes. And the problem is a lot of times when you look for documentation, you're not following the path that the author has intended. You may just go, I have this problem, I'm going to Google for it. I'm going to see what's the first thing that comes up. It looks like it's an official documentation. Let me see if that helps me. What happens then is you're not landing on the right version probably. You might be using version 2 while you've landed on version 3's documentation. And it's a very frustrating experience when things don't sort of add up to what the documentation says it should work and what actually works. Now, I really like Python and Django for the documentation because it'll call out the fact that this is version 3 documentation or you're looking at an outdated version's documentation. Django gets this right particularly well. If you look at the development version of Django, it will tell you this is the documentation for the version of Django that's not yet released. If you invariably end up there, you know that, hey, this is not the version I'm using. I should probably like change the version in the selector and go back to the version I'm using. Because I've made this mistake a couple of times, so I know how frustrating it is. And I've been part of a project where we made this decision that we would only have one version of the documentation. Our thought process was, hey, we don't want to maintain separate branches for documentation. We just want to maintain one branch. So let's maintain everything in master. The problem then is we've mixed up the API for 2.0 with 2.1, with 2.2, with 2.3. And sometimes we forget to add a callout that says this feature was added in 2.3. And now they're using 2.0. And the users have no idea that this is not supposed to work in their version. It doesn't work. And they file a bug and complain to us saying, hey, you guys have said this should work. It isn't working. And it even took us some time to figure out what went wrong. I mean, we're looking at a code. It's supposed to work. We're looking at a documentation. It says it's supposed to work. What did we do wrong? It turns out that feature wasn't added in the version they're using. Don't assume that users know your jargon. So I work on Gluster now. Gluster has this, the two words that Gluster uses. One is bricks and one is volumes. It's peppered all around the documentation. I've been working on Gluster for about, I think, 8 to 9 months now. 3 months ago is when I realized what the difference between bricks and volumes are. We have documentation on this. It's in a file called Glossary. I didn't see that file. I didn't think to look there. I mean, what I'm looking at is installation instructions. I'm looking at how to compile Gluster. What I missed looking at is the glossary that was at the end of the documentation. So don't assume that users know your documentation. Like I said earlier, you don't control how users come and reach your documentation. Once they get there, your job is to make sure they understand what's written there. So if you have some jargon in your documentation, the first time it appears on a page, link it to the glossary. Link it so that if you don't understand it, it will tell you what that word means. One bit of documentation that I find really, really annoying is there is an example of how to use this library. Try out the example, it doesn't work. Most likely because something changed, and during the release, we forgot that we had to update the examples, and people started complaining, and that's when we realized, oh shit, I broke, or we changed how this API works, so this example that we have in our notes doesn't work anymore. What I fully recommend is when you have tests, write tests for those examples. If your documentation has changed, if your test has changed, it will fail. Or rather, if your code has changed so that the example doesn't pass, your test will fail. When the test fails, you know that it's a documentation test, and you have to go back and fix the documentation so that it passes as well. This is something that we overlook when we talk about documentation. Release notes. You've released your new version of your fancy product, and you've deprecated 3 APIs, you added 2 APIs, and the output of a third API has changed. Your users need to know that before they upgrade. I cannot stress this enough because I've been bitten by this issue several times from code that I wrote. So I can happily admit that I've made this mistake as well. And so this is an example that I want to show. We use Gerrit for code review. Gerrit is a Java-based web app that lets you push code and submit review requests. It's somewhat like GitHub pull requests, but Gerrit is far more flexible in terms of the power it gives you. This is what the release notes look like. I know it's kind of small. So if you look at the left section, it says important notes. The important notes are bits that you have to read before you install that version because they've deprecated something, they've changed something. The new features are important, but before that I want to read what's happened there. And if you look at the hooks line on the right side bottom, what happened is how server-side hooks have changed. It's now a plugin, and if you want to use it, you need to install it. That's really relevant for me because we use server-side hooks. And if I had not seen that, I would have been in big trouble after I deployed it. If that was not documented, I would be in big trouble. As programmers, we tend to get really smart about release notes. We'll say, hey, so I'm going to write the script that will do a git log. It'll get all the commits that you've pushed into the repository. And we'll take the first line of those commits and add it to the release notes. Hey, we have release notes. No, don't do that. That's bad. What ends up happening is your commit messages are for developers to read. They're not for your users. I mean, can a second person who's reading your commit message understand what you changed in that one line? Most probably not. I mean, I can't understand my commit messages after a couple of weeks. Like, I have to figure out what the diff looked like. And when I talk about release notes, this is what I talk about. As you need to make a human readable release notes. Like, think about the users who are using your product. Think about the people who want to upgrade to your new version. Give them a reason to upgrade. They should know what things they should watch out for. They should be able to make an informed decision whether to do this right now or not. I mean, yes, I can install it in staging. I can test it out. But ideally, I should know what I'm getting into. Testing. So the first was Cadence. The second was documentation. The third is testing. Here's the thing. Python is a great place as a programming language to talk about testing. We have at least 3 sort of mainstream testing frameworks. There's unit tests that comes with Python. There's nose. There's PyTest. And I'm pretty sure there's way more. But there's quite a lot of testing frameworks and sort of options that you have. I mean, I look at C, and there are a couple of options, but they're not as well known as you'd think the Python tools are. When you start programming, I mean, tests don't really make sense. I mean, your thought process is, I know how this code is supposed to work. I know the output that it's supposed to give, and why the hell am I citing a test for it? This particularly happens with unit tests for me. The first part about testing is linting. Before we talk about linting, you need coding standards. Every large code base usually publishes its own coding standard. I believe the Linux kernel has a certain standard, and it has a linter. Before you commit, you need to make sure that your code passes the lint before it gets into mainline. If you have a certain sort of coding standard, you should probably have one. If you don't have one, you should have one, and you should enforce it with a linter. In Python, there's a lot of them out there, depending on what you're looking for. There's pep8, there's flake8, which is pyflakes and pep8 combined, and there's pylint, which I haven't used, but I've heard good things about. This is the bit where I said, it doesn't make sense to me why I would write a unit test for something. So this is a factorial function. You know, Hansa was right, because last night when I wrote this function, I actually made two different mistakes. The first one was, actually this is still a mistake. The first one was that instead of a multiply symbol that I had a plus, and I was trying to figure out why the result was wrong. And I think it still has a mistake where fact should not be 0, it should be 1. This will probably fail. Now, the point is not how this works. The point is, tomorrow you decide, I'm going to rewrite this function to use recursion. If you have unit tests, you don't have to worry about it, because if your unit test passes, the function is right. Unit tests take very little amount of time. It's not using your entire stack. It happens very quickly. This is why unit tests are important. When you start writing it, it doesn't make sense. When you have to refactor your code, unit tests make a lot of sense. Integration testing, or people also call it functional testing. If you have a web app that returns the factorial of a number, you'd have a page where you enter a number. It'll call the factorial function and will return an output. You can say, I don't want to do unit testing. I'm just going to write one integration testing to do, call the function, get the output. That makes sense in some regard. But now when you make a change to the factorial function, it could fail because something in the middleware has failed, or something in the controller has failed, or something in your template has failed. You don't really want to do that in integration testing. You just want to know, is the function being called that will return the factorial function? Is the output of that function displayed on the screen? That's where integration testing comes into the picture. And scenario testing is something we need in Gluster a lot. We have a product which can be used in, there are 5 different volume types, and you can mount it with either fuse mounts. Well, there's basically a different set of combinations you can use. You can't test every single combination. So you have to decide that I am going to test the combinations that my users are going to experience the most. So that's where scenario testing comes into place. Not everything can be tested automatically, and that's okay. I mean, coming back to my example about factorial, if you want to test that the output is the center, horizontal center, that's a really hard thing to do in CSS, apparently. I'm not a front-end person, I'd probably struggle with it. It's kind of hard to write a test to tell you whether that output is on the middle of the page for all screen types. But it's very easy to do that visually, which means you may not write a test for it, and that's okay. If that saves you time, that's fine. Last point, empathy. So empathy is the ability to understand and share somebody else's feelings. As a programmer, we tend to think a lot about our code. We tend to think less about the people who are affected by the applications we write. I mean, just think about writing a POS software for a supermarket. You'd have to take into account the amount of work that the cashiers go through, the amount of work that the developers who might want to build on top of it go through, because they want to customize your sort of generic POS application. Or you want to think about the sysadmins who are going to deploy this application to like hundreds of computers. You want to make it easy. And for your sales team. I mean, we tend to have a lot of apathy towards sales team, but you really should make their life easier. I mean, if they can't sell, you have a problem. Trust me, you do. So for developer experience, this is my example. Remember how easy or how difficult it was to make HTTP calls before the request library? It was a lot of boilerplate code. It was really hard to read. And I remember I tried to write an OAuth application based on the old code. And I just gave up for the sheer sort of amount of boilerplate that I had to write. OAuth is difficult, but writing it with a difficult set of libraries is even more challenging. So this is the sort of summary of my talk. Cadence, documentation, testing, and empathy. This isn't a summary of everything that will be important for the release. This is the 4 things that I think are most important when you're doing release management. There's a lot of other things. If you want to talk to me about other things that you've discovered in your career, come talk to me after the talk. Or even if we have time, we have 5 minutes for questions. One bit is I want to call out Jennifer Davis and Catherine Daniels. They wrote a book called Effective DevOps. If you are an ops person, if you're a DevOps person, you should probably read that book. It has a lot of knowledge about getting this sort of culture of empathy around when you work with different teams. Okay, questions?
So what is the role of automation tools like CI tools and Fabric and all release tools, automation release tools in making release? Like,
so
what is the exact role of these tools? Like?
Okay, so the question is, what tools would I recommend, or
should we use tools for the release, or
should we like do it manually?
Yeah,
yes.
manually.
Okay. So what we use is a mix of Jenkins and a couple of handmade shell scripts. I think they need to be completely thrown out and rewritten. Ideally, a release to me should be you click a button and it's done, because the more manual steps you add, the more the chances of mistakes come into place. So you do not want a chance for human error when you're doing a release. That's my point of view. As far as what tools I'd recommend, I don't have a particular recommendation, because no recommendation that I can give you will work across like the whole scale of applications that you may be developing, because the tools that you use for a web app is not the tools you'd use if you're developing a library, and that's not the tools you'd use if you're developing the Linux kernel. So that's a little bit of a very difficult to answer question. Like the ones that come to my mind at the top of my head is something like Travis CI for running your CI, or Jenkins if you want to host your own. There's a whole load of tools out there, and I can't recommend a single one. Like I can't highlight one. Yes.
Thanks for the very informative talk. I just have one question. You mentioned that the environment variable was missed out when you're doing RM minus RF. Do you know what was changed subsequently to fix that?
So what happened was that I was trying to clean up the machine manually, and what I instead did is that there is no more manual cleanup. If a machine has a problem, I am just going to re-image the whole thing. I mean, we take daily images and we just replace the machine with a new image. Yes. Yeah.
You told that single line commit messages don't help actually, and like Linus Torvalds also said the same. Do you have any like suggestions, because platforms like GitHub are not actually helping with that?
Okay. Single line commit messages don't help in a certain context. It doesn't help when you're using that as your release notes. Single line commit messages do help when you're glancing at your Git repository. I think that if it's a complex change, have a single line commit message, but also have like a paragraph of your changes. Like you can use more changes, you can use more lines below your first line to sort of explain what the change did. Because the point of commit messages, 5 years down the line, you've left the company, everybody else who worked with you have left the company, there's a completely new team, and they have to know why you did it in a certain way. Because there's obviously a reason. Because if I'm going to go down a different path, I need to know that you didn't already think of it, and you didn't already roll it out. Make sense? Somebody there had a question?
What exactly is DevOps? Is release automation itself is DevOps, or is it using the different tools like Puppet, Chef, and all the teams?
Okay. So the question was, what is DevOps? Is doing a release DevOps, or is it using tools? Neither of them are DevOps. I mean, the effective DevOps sort of defines DevOps as a collaboration between the development team and the operations team. So in the past, there would be two silos. Developers work on their code. Sysadmins deploy them. Developers might break production. which means there's an animosity between the two teams. I mean, sysadmins see developers as the people who break production, and developers see sysadmins as the people who refuse to deploy code, and just have, there's a lot of stereotypes. I'm not going into that. But the DevOps movement sort of unified the roles so that the teams were working with embedded ops people, so that developers and ops people could communicate and do their work more efficiently. So,
Hi.
yes.
Hi.
Yeah, so here's my question.
This is the last question, yeah.
Okay.
Yeah,
So,
at this side.
Yeah.
Where does version control system plays role in release management? And in which flow would you recommend if I have to deploy continuously, let's say weekly deployment?
Which what?
I have to deploy weekly.
Yeah.
So which version control system would you recommend, and which flow?
Which
Workflow.
workflow? Okay. I don't have a recommendation because it's entirely dependent on your team dynamics. If you want to deploy weekly, you have to sit down with your team and figure out what that involves. I mean, that may involve you sit down with your product manager, your ops person, your documentation person. You sit down and figure out what this means, as in what is the amount of work that's needed to be done, and how can you get it done, and how can you sort of get that pace there. That's like, I can't recommend a solution that works for everyone. It entirely depends on your team dynamics. I am out of time, so find me at the hallway if you have more questions.